and welcome to episode 2 of the Sci-Fi Podcast. From Bloomington, Indiana, I'm Nick Zoutra. I'm currently enjoying having just completed my 7th semester of my dual degree doctoral program in History and Philosophy of Science and Cognitive Science here at Indiana University. Nearly all my coursework is complete. I just have to give a talk in the Cognitive Lunch Colloquium next term. My qualifying paper was recently approved, and my grading is all done. Oh, that feels so good. So I have that feeling of having about 2 whole weeks free before it all starts again, which is pretty exciting. I'm also enjoying the winter weather here, if you can believe it. It's gotten to be about 15 degrees as a high in Bloomington, which is pretty dang cold, but it's still nowhere near as cold as the polar vortex of 2013, my first semester here from coming from Tempe, Arizona. And I think I'm enjoying this quite a bit because my wife and I recently got our own place, a lovely 2-bedroom just south of campus. And thus, this is the first winter without the graduate student thermostat wars. These particular wars of 2013 through 2015 took place when my wife and I lived in a wonderful communal living space, also just south of campus, with a number of other graduate students from differing disciplines. But it turned out we all had our preferences for the particular temperature during the winter months. My wife and I really appreciated the temperature of being around 70 to 72 degrees, which is probably to some Midwesterners and Canadians, such as my roommates, extremely warm. And so we would often during the winter months turn it up to that temperature, only to see it turn back way down to 60 degrees, 62, 64 degrees. We eventually came upon a compromise. Temperature, I can't remember exactly the temp, but I must say it is nice now living, my wife and I living on our own in our own place where these podcasts are being recorded, that we can control the temperature during the winter months. So in episode 1, I mentioned one of the questions that I was generally curious about, and which what motivated me to start this podcast, is that what does it mean to do good philosophy of science? And I think what it means to be a good philosopher of science, or to do good philosophy of science, is it means that someone who actually pays attention to how the science is actually being done. And this concern has come from the idea that philosophers of science traditionally have ignored the details of scientific research. And the result has often been theories that lack relevance either to science or to philosophy in general. So it was in the book that this idea was particularly well represented, the book Toward the Naturalistic Turn, or How Real Philosophy of Science is Done, which came out in the early 90s, where leading philosophers of biology discussed the limitations of this tradition of philosophy of science removed from the science and its advantages, which they called the naturalistic turn, the idea that the study of science is itself a scientific enterprise and should be conducted accordingly. This book featured very lovely quotations, such as from philosopher of science Philip Kitcher, who said, "Why can't we have both theoretical ecology and natural histories lovingly done?" And a lovely quote from Elizabeth Lloyd, "Don't underestimate the arrogance of philosophers," which I thought was pretty funny. But what happens when we focus on the science as philosophers of science too narrowly? This is one concern of today's podcast guest, Carol Cleland, professor of philosophy at the University of Colorado at Boulder. So Carol is a philosopher of science by training, but unlike many philosophers of science, such as myself, who began in the sciences, Carol has much more training and, I think, grounding initially in metaphysics and epistemology. And Carol thinks that it is unfortunate that modern philosophy of science has, at times, become rather dismissive of a lot of the philosophical literature, and that some of the philosophers of science who do philosophy of science are not well trained or ignore gaining more training in such areas as metaphysics and epistemology. And I've come to learn from interviewing Carol that she has found her success in the philosophy of science, not only by focusing intently on the sciences, as this program and myself recommend, but actually by becoming familiar with the previous arguments in analytic philosophy, in metaphysics and epistemology. So, for example, her argument that the methodology of historical sciences is different from that of the experimental sciences is actually drawn from the literature from David Lewis on the asymmetry of overdetermination. Secondly, her arguments more recently that it is a mistake to define life is actually taken from some of the epistemological work from Hilary Putnam and Saul Kripke. So after interviewing Carol, I think this is a very interesting lesson for that contemporary philosophers of science can take, that it might not only be important to do philosophy of science in a way that pays very close attention to the scientists, but it's also important to potentially pay close attention to what philosophers have done, or what current philosophers, for example, in epistemology and metaphysics, in ethics, are actually doing, and whether drawing or applying these kinds of ideas to your own philosophy of science can be a fruitful line of work. So, anyways, it was a wonderful chat with Carol. We had a lot of fun talking and relating. She has a wonderful story. I think you'll really enjoy hearing about it and listening. So, without further ado, let's bring in Carol. So, you grew up in Harvard. Were both your parents? Were they both farmers, or?
No, well, they were both just certainly farming children. Okay. My father owned a farm that had been in the family for a long time. Mm-hmm. My mother was a school teacher. Oh, okay. And basically, my father didn't really like farming that well. So he really wanted to be an engineer. And he went back to school and became a mechanical designer. And he was so good at it that he functioned as an engineer, and he trained engineers. And he sold the farm. Mm-hmm. In the late 1950s, early 60s, I think it was 1959, and we moved to Arizona because he couldn't. The farm was big; it was a very large farm, and he and his brothers had worked it for their father. But once it was just his farm, it was really hard to work by yourself because it was so big. And the people who, so basically, he just sold it and. The land, there wasn't much money you could make at the time. They were trying to get people to put land in the land bank, and he didn't want to do that. So anyone to do engineering, so he sold the farm, and we just headed west.
Oh, okay. Well, great. So, and you mentioned your mom was a naturalist?
Yes, she was. She actually knew Roger Torrey Peterson, the great bird watcher. I have books that are signed by him. He was the one who wrote all the books on North American birds. She was a grade school teacher, but she had been very interested in biology, particularly natural history, and she spent a lot of time as a young woman going to camps and adult camps, which were very popular then. And as I said, Roger Torrey Peterson was one of the speakers. She knew him, and some of the other great naturalists whose names I don't know.
Yeah, it looks like he has a project, the Institute of Natural History. I don't know if that's been around for a while or if that's a relatively new development. But well, that's
it was. She was. This would have been the 30s, I guess. It would have been.
Oh yeah.
So it was a period of time. She was a young teacher, and there were a lot of people at that time who were really interested in natural history. So. I have a book signed by him. She put a piece of Scotch tape over the name so it wouldn't wear off. It's really cute.
Oh, so growing up, was this something that were you at all influenced by the way in which your mom was interested in as a naturalist?
Oh, I'm sure. Neither side of the family had scientists. What's interesting is I was always really interested in science.
Okay,
I wanted to be a scientist initially. Naturalist, and I wanted to be an archaeologist. That was when I was in Arizona and scrounging around the ruins.
Oh, sure.
And then I wanted to be a physicist. And I went off to college. I was actually in the College of Creative Studies at the University of California, Santa Barbara.
Oh.
It was the first year of this college. They accepted a small number of people who were viewed to be creative in their disciplines.
Wait, creative studies, what is that?
It still exists. It still exists. I don't think it's quite the same, but I was in the first year, and there were I think there were two undergrads and they picked people who were just coming in, freshmen, and then they picked two upperclassmen. So I think there were two freshmen, maybe there were three, I can't remember. And then there were two upperclassmen. So there were five of us in physics, and then they had people in biology, and they had people in English, literature. And it was just it was an interesting experiment. As they said, it still goes on. It still is around. You can look it up. But I was admitted in physics because when I was 15, makes me laugh, but I invented a new theory in physics. I was so interested in theoretical issues. It wasn't very good. But
well, still.
I was so astonished that 16-year-old, right?
So what was this theory? What was this?
Well, I called it I can't even remember what I called it now. It had to do with, I just did some simple mathematics and I was claiming, I can't remember. It's been ages and I haven't thought about it. And it was,
sure.
But it was, I knew enough general relativity and special relativity that I impressed people. And it wasn't, I guess, some of the stuff I did was, not completely stupid. So they admitted me. And I was the only woman who was admitted. And it was kind of awkward. In fact, when I first went in there, the guy who was... Was
this in physics or just in the whole college?
In physics. Sure. He admitted to a specific thing. And the guy who admitted me in physics was interesting because he said something about, we weren't going to admit any women.
What?
Yeah, he said. 1967, we weren't going to admit any women. He said, but you look so intriguing, we decided to admit you anyhow. I was really shocked. I never got over that.
What a welcome message.
Very hard to participate as the only one in that group after that's the way I was introduced to the group. There were 5 of us, as we said, when we were introduced to each other. So I've never forgotten that. That was just kind of shocking.
Yeah. How did the climate continue on after that?
It wasn't first of all, the guy his name was Herbert Broida. He was experimentalist, and he really wanted experimentalist in his lab. I don't think he was, and I was really interested in these grand theoretical things. So it wasn't a good fit. And I switched. I didn't stay in physics. I started out in physics. I didn't like labs. I absolutely hated labs. I was always the last one who something was wrong with my equipment. Mm-hmm. So, it's just like when I cook. When I cook and I follow a recipe, I never come out with the same thing.
It's surprising that there's some of these procedural tasks. I know, I myself, it's lab work it can be tough. It could just getting it to do what you want it to do.
My dishes always, they usually turn out good, but they never turn out exactly the same. So I'm not really good at following procedures, which probably explains why I've written a lot of papers on effective procedures. I don't know whether you looked at my CV, but I've also done a lot of work in computability. I ended up with a degree in mathematics. But I explored various sciences, and I took all the senior level physics courses because they didn't have labs, and I was really interested. But I couldn't graduate in physics with all those courses, so I had far more than a minor in physics. And then I tried geology, and I loved the field work in geology, but there were no women. I was the only woman in the field, so that was kind of awkward.
Yeah.
When you approach a campfire, all the conversation dies. Really.
Oh, geez.
I had a lot of chemistry. I had 2 years of physical chemistry and a year of organic. And I was just trying to find a major that I liked.
Yeah. But you knew, so at the time when you were thinking, like, what do I want to be when I, grow older?
Scientist of some kind.
Scientist of some kind in some field. Yeah.
It was originally a physicist.
Okay.
And I really like going out in the field. And I do like earth science a lot. And so I was very interested in that possibility. And finally, I wandered into philosophy. I just took a course by accident. And I thought, oh, this is it. This is what I love.
How did it click for you?
How did what?
How did you come to find out? Like, what was it about it that just made it, this is what you love?
It was very theoretical, I think. And it asked kind of the big fundamental questions that I'd always wanted to ask. When I took quantum mechanics in physics, I found it really baffling. And I always joked that's what made me leave physics. That's not true. It's the labs. But quantum mechanics, when I was taking it, I would ask the professor a question. He would say, go talk to the philosophers. He says, we don't worry about that kind of stuff. So that kind of got me interested in philosophy. I discovered it my junior year, really. But I graduated taking overloads for 5 years before I found what I wanted to do. And then I ended up that I found philosophy, but I I would have had to take even more time to complete all the requirements. So again, I took the upper division courses. We didn't have the introductory history courses, which were required at that time to get a BA in philosophy. And I sat down one day with my then husband, and he said, you ought to think about getting a degree. I mean, you've been in school taking overloads now for 5 years. And so we sat down and went through all the courses that I would have to take in order to graduate. It was a major. We looked at all the different majors, and it was mathematics. They needed only one course in math because I'd taken all the mathematics for the physics major, and I had a real interest, of course, in foundations of math. And so I'd taken a lot of logic and set theory courses. Yeah. So I'm the accidental math major. It's the one.
Not even set out to do that. That's something.
Seriously entertained pursuing. I just ended up with it. Yeah. But it certainly served me well.
Sure.
It was very valuable.
So after undergrad, what were you thinking? What was the plan?
Well, the plan initially was to computer science was just burgeoning at that time, and so there was this little startup company called Culler Harrison in Santa Barbara, and I was married to a biology PhD candidate who was a couple of years older than I was, and so we were going to wait until he finished his PhD, and I got a job with this little startup computer science company, and there were something like 12 of us all together, and we did both the hardware and the software. It was quite exciting.
Wow, yeah.
We built the computers from scratch, and we had software people who programmed them. And when I left, we didn't have a Fortran compiler done yet. If I had stayed, I would have done the Fortran compiler. But we had done stuff in machine language, coding in Octal, which is amazing. I mean, because you're actually just coding various instructions in numbers in the base 8. And what was really interesting is that this machine that we built was being paid for by the Navy. We had no idea what the purpose of it was. It was top secret. And it turned out that it was designed to locate every submarine in the world by active and passive sonar, so that presumably if there were a war, Soviet submarines they were interested in, you could launch missiles at them. You could know where all the Soviet submarines in the world were. So it was the very first parallel processor, and it was later sold to Floating Point Systems as their array processor. So it's probably, I'm sure know about the array processor, but in the 80s, everybody knew about it because it was the first parallel processor. It was very hot, and we did the prototype for it. So that was exciting.
Wow. Okay. So how long were you working as I suppose, software and hardware engineer?
2 years, a little less than 2 years.
Okay. And how was it like working? Sounds like it was exciting.
It was really interesting. It was interesting, but also frustrating. It wasn't like working in a company as now, because it was basically a little think tank. The person who was running the company at the time, Glenn Culler, was a professor of mathematics at UC Santa Barbara. I had actually taken a course from him, coding. And in those days, there weren't departments of computer science. There were departments of mathematics with computer scientists in them, mathematicians who were interested in computer science. Glenn Culler's big ambition was to solve the speech problem of recognizing human speech. Sure. And that's why he was writing these really incredible parallel processors, so he could compute fast Fourier transforms much more rapidly, because they thought that was all you needed to solve the speech problem, was just to have more computational power. It turns out that's not true, but that was the hope at the time. So it was kind of fun. There would be discussions about various problems, and get us all into a room to talk about it. We were all very young. There were peace symbols all over the place, and I remember when they did the acceptance. Basically, the Navy required some acceptance tests for the mathematical transforms. I wrote them. And when the Navy came to accept the computer, the secret computer, we didn't know till years later I found out what it was for. But they had all these Navy admirals, with their uniforms and their medals all over their chests, and they came in. And we were all had our peace symbols. They were up all over the place. This was the 70s, early 70s.
Oh, geez.
There were peace symbols all over the place. We had long hair. We were all hippies.
Yeah.
We're all under the age of 27. And it was so funny because the guy who basically ran the company, and it wasn't Glenn Color, there was a guy who was the official administrator, ran around telling us to take down all our peace signs, telling the women we had to wear dresses.
Oh, geez.
So it was really quite amusing. And then the brass shows up, and it was quite amusing because I had written the acceptance test. That was my job, because I had a degree in math. I was doing the mathematical transforms, and you had to punch a button on the screen to make the screen light up when you were looking at it. Otherwise, it went dark to save the screen. And so at some point, we were all huddled in a room together to sort of stay out of the way of the admirals. Mm-hmm. And one of the admirals poked his head in and said, "How's it going?" And I went to reach over to poke the screen so he could look at it, and he grabs my wrist and he said, "Lady, don't touch that. I don't want anybody to mess anything up." And the guys in the back room started laughing, and the admiral looked at him and he said, "She wrote the test." He still didn't let go of my hand, by the way.
Oh, my God.
He did not want me to touch that screen.
Oh.
So the guy who was my supervisor reached over and poked it, and he was okay with that. So those are my sort of experiences with sexism. There are actually quite a lot when I think about it.
Yeah, geez, yeah. It's a different. I want to say a different time, a different era. It's not like it's. I would like to say it's gotten better, but I can't speak from experience.
It's people are more conscious of these things, I think.
Okay,
and they're more aware that that women are, equally knowledgeable and intelligent vis-a-vis men. Whereas when I was younger, I don't think that people quite had fully, even consciously, accepted that.
And people were free to carry out this just
assumption,
I think or just
it was very strange. I remember the acceptance tests being bizarre, but remember there were my peers, the men in the room. I was really the only woman programmer, and the men in the room, they thought it was hysterically funny. They laughed at the admirals, which they did not appreciate.
Sure. Wow. Well, that's pretty fascinating. Unfortunately disheartening given the situation.
Well, it's I got through it. I mean, it did go on in philosophy. I remember watching when I was trying to decide what to do, whether I wanted to do this the rest of my life. Mm-hmm. I remember watching. You had to step through a program on the face of the computer, and they had all the registers laid out, and there were lights. And they were arrayed out. There were basically a row of lights for each register, which is what was in memory. There were instruction registers, there were memory registers, and you would step through the program, and then you check to see what was in memory, what the next instruction would be. You could do all that in the computer, and then you'd punch to let it run, and all the lights would flicker. And I remember thinking about consciousness and just computability, and I thought, there was some really interesting things here. And I remembered my philosophy courses, which I loved. Mm-hmm. So my former husband at that time had got his degree, and he was going to be at Southeastern Massachusetts University as an assistant professor. Mm-hmm. And so Brown was the obvious place to go.
Yeah.
And so I ended up at Brown.
And so you went to Brown, I see. How was who were you working with over there?
Well, I worked with Ernest Souza. He was a wonderful advisor. He was very supportive. I had a pretty good time at Brown. There weren't many women. I think there was one other woman in my class, and then there was one who was 2 years ahead of me. That was pretty much it. Mm-hmm. So we didn't have much to do with each other. But I do remember Brown very fondly. I don't remember ever being treated as anything but with respect. And I remember, as I said, Ernie was a really great thesis advisor. He was very encouraging. So I had a good time at Brown.
That's good. And did you go in as interested in the sciences, but finding yourself really interested in philosophy? Was philosophy of science in particular something you were looking at?
That was a sad thing. I actually went there because I thought there was a lot of philosophy of science.
Yeah.
I entered the year Steve Leeds left. And they had another philosopher of science who was from MIT. I cannot remember his name. I don't know whether he continued. He was a lecturer in philosophy of physics, and he was there for one semester. And so I took a course with him, and I was pretty naive about, the fact of faculty turnover. He didn't continue, and I don't know where he went. And Steve left. He left the year I entered. So I ended up basically, there were no philosophers of science there when I finally got there. So I did metaphysics and epistemology, which was incredibly valuable because it's given me this metaphysical and epistemological perspective on philosophy of science, which a lot of, especially contemporary philosophers of science, lack.
Yeah, tell me about that. I feel like there's, I don't know if this is perhaps accurate, but there might be at times a tendency to not, to maybe just separate the metaphysics and epistemology work from contemporary philosophy of science.
There is, and I think it's very sad. And my work in philosophy of science, I would say, is much more metaphysical and certainly much better trained in metaphysics. I don't mean to be offending anybody, than most philosophers of science. A lot of philosophers of science come in with degrees in science, and then they proceed to focus very narrowly on doing philosophy of science. And been rather surprised in talking with other philosophers of science at how, I hesitate to say this, but their backgrounds in metaphysics, which I think is really crucial to doing philosophy of science. My work, I'll talk about that in a minute, really is heavily embedded in metaphysics and epistemological issues. And so I really feel strongly that that's, I think, a deficit in modern philosophy of science. So my work on historical natural science, I extensively use the asymmetry of overdetermination. David Lewis identified it as the asymmetry of overdetermination. He wrote on it. There were debates about it. And that is a key piece of my argument that the methodology of the historical science is different than that of classical experimental science. I'm taking all of that out of that metaphysical literature. Similarly, my arguments that it's a mistake to define life are taken out of the literature for, Putnam and Kripke. I don't endorse the causal theory of reference, but you can view Putnam especially as having two basic prongs to his argument. One is a criticism of the descriptive theory of reference. I think that succeeds wildly well. And that's all I need for what I do with regard to arguing that it's a mistake to define life. I don't need the pure causal theory of reference. I think probably a hybrid theory of reference is the right way to go. But the criticisms that come out of Putnam and Kripke's work on reference are just, particularly for natural kinds in general terms, powerful. And those play a huge role in my stuff on the nature of life, definitions, theories, the nature of theories, etc. So I borrow extensively from my wonderful background, very good background I got at Brown, with Chisholm and Souza and others.
So was your coursework primarily in philosophy, or did you deviate at all into the sciences? Or
Well, that's a good story, because actually my coursework was all in the sciences, but because I was a really good programmer, it turned out that I ended up doing programming for the first what do they call it now? Jim Anderson was in the applied math department at Brown, and he was working on distributed networks, distributed memories. He was one of the first people to work on that, and there's a buzzword I'm forgetting here. And he, it turned out that he had a graduate student who had gotten his PhD, and he needed a programmer, and he wanted somebody to actually program these massively parallel distributed networks, neural networks. And they were not real real neural networks. They were, basically massive high-dimensional matrix transformations. And so he and I talked, because one of his grad students was taking a philosophy course, and he recommended to Jim that he hire me, and so Jim and I talked, and Jim hired me. So actually, my third year there and fourth year, I made much more money than the other graduate students because I was being paid as a research assistant in the applied math department to do these, to do this programming task.
Wow. Okay. So you're continuing doing programming.
Yeah.
Learning.
No, it's really interesting. And at the time I thought I might do philosophy of mind. But I decided I think mind is really hard. And so I'm much more of a natural scientist, I think, than I am a social scientist. So I decided I did metaphysics initially. I mean, initially until the 90s, I was doing supervenience, weak non-supervenience. I was interested in causation, individuation of events. The work I was doing was in metaphysics and not in philosophy of science. My work always had a philosophy of science aspect to it. I would always draw on examples from philosophy of science. But it wasn't until the late 90s that I actually started doing nothing but philosophy of science.
So it was more, would you say it was more a philosophy of science used to inform philosophy or inform metaphysics? Like you would draw?
I was really doing traditional metaphysics. I mean, I was Brown, PhD, and I'd been well trained to worry about events and causation and various logical relations like supervenience. I invented this kind of what I call weak non-supervenience, and I was originally going to do more work in that area, and I renamed it as covenience, but I never actually finished pursuing that.
Yeah, I see some of your first publications here on causality, chance, weak non-supervenience, and
exactly.
Yeah.
And that was classic metaphysics. I mean, I drew on things such as I was hoping that my account of causation would solve certain problems that people had in causation with quantum mechanics. And I knew quantum mechanics, so I could give more detailed examples than perhaps some people. But it was really metaphysics I was doing. Okay.
So did you graduate? Was that your dissertation work?
Yes, my dissertation was basically on causation, the metaphysics of causation.
All right. So, so you do your work at Brown. Was this, were you thinking academia for sure, going in as trying to get a job as a professor or?
Oh yeah, no, by then I really wanted to be a professor. I wanted the freedom to really pursue intellectual topics and to solve problems. I didn't really want to work for somebody. I had tried that out when I was, even when I worked with Glenn Culler, it was more like a think tank. But, we were told basically what our projects were. And I wanted to do my own projects.
Yeah, and I think we actually didn't cover that. So as far as moving from doing software and hardware engineering to, graduate school, I mean, was that some of the impetus for that, like wanting to do your own thing?
Yes, it was. Yeah. It was. I had decided I really didn't want to work in a company. And also I didn't like the fact that people would there was not as much stress and perfection getting it right. I don't mean perfection. There would be stress on making it work. And so what if it's a kludge? We got to get it out the door. Yeah. And so it was this kind of getting it out the door mentality when things sometimes could have been done a lot better, but we had to get it out the door. And so some of the stuff was kind of taped together.
I could see that be kind of frustrating.
And it wasn't my project. I mean, it was Glenn Culler's speech project. So it was interesting. I mean, it was fun solving puzzles they needed solved and writing. The cat is playing with the eraser. I'm going to have to remove him now.
Sure.
All right, cat, out you go. I know you're not going to be happy about this. All right. He'll be quiet. Okay?
Okay.
I'm back. He's out. So I can't remember where we were.
I think we were talking about just some of the dissatisfaction with working as software. Yeah,
I really like being my own boss, and I really have interesting projects. And at the time, as I said when I left, I was interested in doing philosophy of mind because I've been thinking about computer, about intelligence, cognition, about mind, consciousness. But and that's partly why I eagerly accepted the job working with Jim Anderson's stuff at Brown on parallel distributed neural networks.
Now, was this while you were a student, or was this a postdoc?
Well, a student, Brown.
Oh, yeah.
Yeah.
Okay, great. So take us through after grad school. So what did you go on to do?
Well, I was initially at Wheaton College in Norton, Massachusetts, not the religious one, but the one in Norton, Massachusetts. It was still a women's college. And it was really fun. I didn't think I'd like teaching at a women's college because I'd always gone to co-ed colleges, but I actually really enjoyed it. The classrooms, the young women were much more, they weren't quiet. They actually talked a lot. So I was really impressed that that you could have this dialogue with young women in a class where it seemed like all of them were participating and no one was really dominating the discussion to the extent to which in my classes at certainly Santa Barbara, the women rarely said anything. So I thought that was a really good thing. And I formed some really nice relationships with my students. So I enjoyed that part a lot. But it turned out that for institutional considerations, namely the department was 2/3 tenured, and I was informed of that just before tenure, that no matter how good I was,
really?
I could tenured. Yeah, no, I had the impression it was a tenure track job. I think it was listed as that, but it really wasn't. And
wow.
Yeah, it was very strange. To this day, I still don't understand what happened. But as soon as I got a letter from the administration saying this is to tell you that due to institutional considerations, you may be denied tenure on the grounds other than your quality of research or quality of teaching. I got a letter like that.
I don't know. Yeah, I don't know. I wouldn't know what to make of that.
Well, I went and talked to the two philosophers, and they made it clear that they believed that they wanted to keep that third slot open for other people. They didn't want to, as one of them said, they wanted to be able to get new blood.
Wow.
And so I left.
Sure.
I left and I went. My former husband also left his academic job, and we both were going to be part of another startup computer company.
Oh, okay.
The company that was being put together, it's called Motion Analysis Corporation, and it was being put together by a graduate student of Glenn Culler, the same guy I'd worked for at Culler Harrison in Santa Barbara.
Okay.
So we were both hired as engineers. He was a more senior engineer than I was because it had been his thesis project. Had been on motion analysis in biology, looking at organisms and how they move, and he had done a lot of programming. And I was initially going to be kind of a mathematical programmer, as I had been before. I was promised that I could do some artificial intelligence programming, which was very exciting. That never actually happened, but that was my expectation. I would be involved in some artificial intelligence programming. But there was also a new Center for the Study of Language and Information that had formed at Stanford. And I contacted them, and they had encouraged me to come and basically told me that they thought that I would probably get a postdoc with them the following year. So I spent a year at Motion Analysis. And then I went to Stanford the following year I was considered to be a fellow in both philosophy and computer science, which was pretty exotic.
So it was like a joint fellowship, postdoc.
The computer science, they said, because I'd make more money. It was very sweet of them.
Yeah, come over here. Yeah, that's the way. At Indiana, cognitive science makes quite a bit more money than
this was computer science.
Yeah, probably even more.
So I had the official position of postdoctoral fellow in philosophy and computer science. It was quite.
Wow. Yeah, so at Stanford too. How was that?
There, I did my work, the preliminary work for my articles in computability. If you look at my earlier work, I've done a lot of stuff on physical computability. The Turing machine,
the Church Turing,
Turing thesis, and all of that work that later came out. I basically is rooted in my 2 years that I spent. Maybe it was only 1 year. I wasn't at Stanford long because at that point. I decided I really wanted to be an academic again, and I was commuting this huge, long commute, and Stanford had basically told me I needed to move down closer, and it was just kind of becoming impossible.
Sure. I
had officially a 2-year position, but I think I only stayed there for a year. I'd have to look, but I'm pretty sure I was only there for a year. And then I applied for jobs, and I ended up at Colorado, 86.
Yeah. So tell us a lot. So how was the job process? How was the job hunt for you?
Well, the job hunt I did pretty well, and I was very selective in my applications. It's truly astonishing I ever got a job in retrospect.
Yeah.
So I applied for about 4 or 5 place that sounds incredible now, right?
Yeah, but a huge success right there.
I had a little girl at the time. She had been born my last year of grad school.
Oh, okay, great.
So she was around 5 years old, 6 years old. Well, I guess she went through first grade at when I was at Stanford. And so we had this kind of complex situation where I could only apply to places where my former husband was willing to come. And so sort of a separation given that. So he had always loved Colorado. And so the Colorado job really appealed to him. And I got it. Wow. And so that's how I've stayed it's lovely here in Boulder, to be honest. And
I bet. Yeah.
Since, yeah.
Yeah. No, that's fantastic. So you've been working there since 1986, you say?
Yes. And I initially did metaphysics. And then my whole life changed in the late 90s, about 1998, I think it was. And that was when NASA, so it's Allen Hills meteorite, which is the meteorite. It turns out that Boulder is a hub. It receives more money, NASA grants, than any other college in the country. University in the country. It's a hub. A lot of the astronauts have graduated here. It has lots of planetary scientists, space scientists. And so when this meteorite was found, it was found in Antarctica, Allen Hills, Antarctica. And that's where you go looking for meteorites, because you can't tell if you're just looking around the ground whether something's a meteorite, because they're often small. But if they have something on top of the ice in Antarctica, you can bet it came from above. So most meteorite hunters hunt for meteorites in Antarctica. They're very easy to find. In certain areas, you just go out there, and particularly where you have the ice that is coming up against the mountain and churning over, and the ice is miles deep, what you're going to find in the surface is primarily coming from above. And so they found this meteorite. They knew it was from Mars because the gases in the interstices of the meteorite matched the isotopic composition of the Martian atmosphere, which had been known since the Viking missions in the mid-70s.
Sure.
And they cut this thing open. It took a long time. They found it, I think it was in 84, and they didn't look at it really until the mid-90s. They cut it open, and they found these structures in it that looked like what would be on Earth called fossilized bacteria. They identified these they're carbonate globules, and they have the shape of bacteria. And when you find those in Australia, which has some of the oldest rock in the world, going back 3.5 billion years, you consider them to be fossilized microbes. So they looked at these, and they found some other structures that were very suggestive. And then it kind of exploded in the news that they had found fossilized Martian life. Sure. And this was a big press conference, and the people who had, actually the authors of the article had done a press conference before the article came out. That was considered to be uncool. Huge fight erupted immediately. Time magazine had a cover called The War of the Words. And Boulder decided immediately to take advantage of this because they had so many space scientists. So they were looking for a philosopher of science. I had been teaching philosophy of science because of my background. They were looking for a philosopher of science, and they found me. And they asked me if I'd participate in a panel on this mysterious Martian meteorite.
Sure.
And I said yes, and I asked them for the papers, and I read all the papers. And it occurred to me that there was a lot of confusion that was philosophical. One of the criticisms were that they weren't trying to falsify the hypothesis that the meteorite contained fossilized Martian life, and they were thinking in a Popperian sense. And falsification in that sense applies to generalizations, not particular phenomena in a rock.
Yeah.
And particularly phenomena that are supposed to be traces of historical events, microbes that were on Mars, 3.whatever billion years ago, because probably 3.8 is, I think, where they were thinking. And so what I did is I began to think about the difference between the way in which the methodology of historical science works and the methodology of experimental science. And I began to see they were really different. So I got really intrigued, did a little more work probably than I should have. Foundation for the work I've done in historical science were being laid there. And I went in, and I did this in a matter of days because I didn't have much time, because they wanted in 3 days, once this news broke, to have this public panel to discuss the Allen Hills meteorite. So I got up there, gave my talk, and as I went to sit down, 2 scientists grabbed my arm and said, "We learned something." I didn't know whether to be insulted or flattered that
Sure.
They don't learn anything. And a year later, I was invited to join. NASA had put together, because of the Allen Hills meteorite, they had put together a Institute of Astrobiology. They had decided it was time to really seriously consider the possibility of life on other planets and moons in our solar system. And this was a virtual institute. They had teams. They basically solicited applications for teams from across the United States, maybe the world. Eventually, the world actually had teams associated with it. I can't remember if it did early on. But Boulder decided they wanted to form a team, and they gave me a call, and they said, "We want you to participate in our team. And we want you to explore this historical science stuff further."
Yeah.
We also want you to worry about the definition of life, because and so suddenly, and they gave me a lot of money to travel to biology conferences, a summer salary, and so I've been doing astrobiology related. I've been doing not astrobiology related. I quickly branched off from that, but I'm doing issues having to do with historical science and its methodology, its difference from experimental science, and issues about the nature of life, the shadow biosphere term, which I invented, came out of that work. And so I've been working in those areas ever since.
That is fascinating. Yeah, and I pulled up, it looks like at least there's one interview with NASA here, at least that is still posted from maybe 2002 or 2003, asking you things such as what is life, and what do you think? Yeah.
They were very supportive. They were excited to have me involved, and I think, one of the nice things is my background, my extensive I didn't have BA in a science, but I had the equivalent of almost 4 BAs. I had I had far more than minors in geology. In physics, it was only the labs I lacked. In chemistry, I had, basically 2.5 years of chemistry. Geology, I had 2.5 years of geology. And so I think this background, it just made me, it's funny because the science had changed a lot since I was an undergraduate. But there's something about when you learn this stuff, you learn really quickly how to pick up the new stuff.
Yeah.
So it was very easy for me to understand the science. And I think the scientists really appreciated that. What they most appreciated is that I've always made a real effort to know the science, not to the detailed extent that they know it, but enough so that I know it to the extent that I'm talking about it. I don't gloss over details. Some things I know in much greater detail than others, and those are the things that are really important to the work I'm doing. So I think that's helped me enormously in terms of my connections with scientists. Some scientists say they think of me as a scientist, but I'm not. I'm a philosopher. There's no question if you actually read my stuff. I've published extensively in science journals. I had a paper in the recent 2013 125th anniversary issue of the Geological Society of America, followed by, it was #1 paper in that.
The GSA?
And it was followed by 2 or 3 people commenting on it. So, yeah, so it's being able to really know how much science you need to know and how much is irrelevant. And because I don't need to know particular chemical reactions unless I'm doing something on metabolism, then I need to know some of the critical chemical reaction sequences.
Sure. So do you get to mentor any graduate students yourself?
Unfortunately, Colorado so far doesn't. I do, but not many.
Sure. Colorado
doesn't have much it's very ironic. I don't understand it. We have some of the most premier science departments in the world. Our geosciences department was recently ranked #1 in the world.
Yeah.
And certain areas of physics were ranked in the top 3, and some were ranked 1. I know physical chemistry is fallen in the rankings, but it used to be in the top 5. So we have some of the best science departments, certainly in the country, and in some cases in the world. And yet our philosophy department has never made a priority to have a strong Department of a strong representation of philosophy of science. I'm hoping that's changing. We just hired Heather Demarest. She's just accepted. She does metaphysics and philosophy of physics. So
Where's she coming from?
She was actually undergraduate here. I was
great
courses from me, so I'm particularly thrilled to get her. And we have Rob Rupert, who does cognitive science, and hopefully we'll get more. And Raul Sacido is very interested in physics. He has a background in physics. So I'm hoping that the future of philosophy in Colorado will have more philosophy of science. But there's been not as much interest as I would hope there is in it. It's a fringe field. I think that's unfortunate because I think that philosophy of science is very important. The humanities are getting more and more isolated from the sciences. Ghettoized, I think would be the right word. And I think one of the ways to fight against that ghettoization is to have these links, have philosophers of science that scientists say, oh, gee, we learned something, or oh, gee, that's interesting, involved, and then they come to respect philosophers more in general.
Well, yeah, absolutely. I think, and it seems like from your experience with ASA and being on that panel, I mean, this is just the more interaction we can promote is something that we can hope to convince one another of that.
It's getting hard. Ironically, it's somewhat harder. NASA was very open at the beginning, but I don't think they're as open now.
No.
I think there's been a shift in their openness to philosophers. I have no idea why. I think part of the problem is I did have name will remain anonymous. I'm not going to tell you who, but I had a top NASA administrator tell me that they had felt burned by at least one philosopher of science who really, they couldn't figure out what this person was talking about, and they were very unimpressed, and this person couldn't seem to learn the science. So I have suspicions who this person is, but I'm not going to say that either.
Sure.
But I think it's really important that you connect with and learn the science. If you're going to work with scientists, you need to really be involved in the science. And I always find this really fun. So I'm on a new project now. I just got invited to join a Templeton grant, which it's by Bob Hazen's running it. See if it gets funded. I think it's highly likely. They think it's highly likely. But it's called, I think it's called Chance and Necessity in the Origin of Life. And one of the things they want me to do, look at the concepts of chance and necessity. But they also want me to look at the concept of mineral, species, and locality. And so they've asked me to do some specific things. Now, I happen to, some people go, oh, do you really want to do that? I'm going, yeah, I think this would be really interesting, right? And so I will be learning more about minerals, but I remember my mineralogy class when I was undergraduate, and I think it's going to be fascinating. I won't spend all my time doing it, but it's related to my interest in origins because he's interested, and that team is interested in the origins of various mineral species. It turns out 2/3, I didn't know this, of the minerals on Earth are produced by biological processes. Would you believe it? Right? Stunning. And so they're really interested in looking at mineral species and their connections to the origin of life and understanding the past history of the planet. I'm just finishing up my book on the quest for a universal theory of life, which is under contract with Cambridge, which is on universal biology and definitions and shadow biospheres and all that good stuff. The next book I want to do is on historical science.
Yes. So I was introduced to your work, friend, in a philosophy biology class on the general approach of explaining the relevance of historical science to scientists, but also as it's different. So why don't you, if you could, give us a little bit of the explanation of your previous work and maybe some current work.
You mean historical science?
Yeah.
I think among philosophers, my work in historical science is best known. Among the scientists, my work on definitions and the nature of life and shadow biosphere is equally well known. It's kind of ironic; it's not as well known among philosophers, but among scientists it is. But particularly space scientists. So basically, I've argued that the methodology, just in a nutshell, of the historical sciences and the experimental science is fundamentally different, and it has to do with their epistemic situations. All science, whether historical or experimental, occurs in the localized present. I mean, you can't look at everything in the universe. Your data doesn't come from there. It comes from either a lab where you bring about a test condition and you look for a result, you make a prediction, or in the field where you discover the remains of an iridium anomaly in a particular location, like in Gubbio, Italy. And then you discover iridium anomalies elsewhere. But it's always local, and it's always based on the present. And you use that information to infer to past events, and you use it to infer the robustness. I prefer robustness to any notion of probability or truth, because I think that's what a lot of experimental science does, of your generalizations. And so rather than the traditional view that you can understand the success of science, its explanatory and predictive power, through a logical relation of hypothesis to evidence, the support of the hypothesis and the evidence, I'm arguing that a lot of times people are keying into causal information. And that causal information comes out of the fact that our world, our universe, has a time asymmetry of causation. This is the David Lewis stuff. Events leave many disparate traces in the future and the present. Events in the past, a volcanic explosion. What do you get? You get not only a cone-shaped mountain, if it's that kind of explosion, but you get masses of magma. You get masses of ash, of pyroclastic debris, volcanic bombs. And you don't need anything but a tiny fraction of that in order to infer that there was a volcanic eruption. And you can date it. Why? Because you have decaying uranium, right, in the magma. And so you have all of this evidence in the present of events, such as volcanic explosions, that go back, millions and billions of years, right?
Yeah.
You can infer back to the Great Siberian flood volcanism, which covered an area about the size of the continental United States to a depth of almost 4 miles, 250 million years ago. And you can be more confident of that than you can of inferring to the next eruption of Mount St. Helens.
Huh.
Isn't that fascinating? And it's because of this time asymmetry of causation. And so that was the initial insight that I got when I was basically preparing to talk to this NASA panel on the Allen Hills meteorite, that, there really is an epistemic difference in your orientation. And that this had been ignored because everybody thought that the rationality of science had to be based on a purely logical relation of deduction, if you're Popper, probabilistic reasoning, if you're some of the the confirmation theorists. Even Bayesianism makes this assumption. And actually scientists are drawing on a lot more relationships than just purely logical ones. So that was the initial insight. I went eventually to write a book on this, and I'm really interested in particularly modeling. That's where my next research is. It turns out that a lot of people don't know this, that modeling, there's a lot of philosophers right now really interested in climate modeling. But some of these philosophers aren't aware of the fact that these models, these climate models that are forward-directed, are actually calibrated with paleo data. Because how else can you infer, right, that the model is how else can you basically infer that the model fits what's going on now, except by looking at past events and trying to substantiate that there was a similar enrichment of carbon dioxide in the atmosphere, or absorption of it in the oceans, or acidified ocean. You need to have data about what amount to past experiments, right, in order to calibrate those models. And then what they do when they calibrate the models is they push them forward into the future, and if they work very good, then they use them to push them back even further in time. Extraordinarily interesting how modeling and field research works. So one of the things I want to do is understand that better. And I really want to look at the use of modeling, computer simulations, in paleo studies. In Cretaceous mass extinction, a lot of the evidence, we have a very rich story we tell about that now. A meteorite, the size of Mount Everest, slammed into, driving at cosmic speeds, slams into the Yucatan, what was then now the Yucatan Peninsula, which was a narrow, shallow, highly productive sea. This is a lot of information. They modeled this, and then they model, exactly what is expected under those conditions, and then they try to connect it to the traces that they find in the present. So it's extraordinarily interesting and complex, and I don't think many people have looked at that. But it's also really critical for understanding the strengths and weaknesses of models, climate models, especially that are future directed.
Well, I certainly think, climate models are a very important topic in the not only in the climate science community, but in philosophy of science as well. Yes. I know we have one professor now, Elizabeth Lloyd at Indiana, who's shifted a majority of her time. I don't know if you guys have spoken or.
Oh, I know Lisa very well.
Oh, great. Yeah. And so I know that she's particularly interested. Her previous work has been on modeling, but I'll be interested to see. Is this something that you hope to pursue more specifically, or?
Yes, it is my next project once I get my book on life done, which the one is called The Quest for a Universal Theory of Life: Searching for Life as We Don't Know It. I'm on the last chapter.
Really? Yeah. When can we expect for that to come out?
Well, Cambridge has been really good to me, but they're bugging me every month. The date, I decided to split one chapter into 3, so I'm doing that split, which has delayed things a little. I'm still hoping to have it done at the end of January and submitted to them. But it might be a little longer, but it's on its last stages. Most of it's written. I still have to write an intro, and they want a big bibliography for further research, which I've put together, but I have to finish up a couple of chapters in the splitting, but most of the stuff's done.
And how would you describe it? Is it a more philosophical book? Is it historical and philosophical?
Philosophical. I mean, the first half is basically, I've now split it in 2 parts. The first half is called The Quest for a Universal Theory of Life. And I argue there that a lot of biology has been basically hamstrung by the Aristotelian legacy. I know a lot of philosophers are still wanting to apply Aristotle to understanding the nature of life.
Sure. And
one of the things I point out is that if you look at the history of science, it's when people basically got away from Aristotle that the sciences took off. If you're looking at physics, or particularly chemistry, the old Aristotelian views in physics and chemistry is fairly recent, in the 18th century, 17th century. It was only when they were able to shuck off this view that water is an indivisible element, and that there are 4 basic elements. By the time of Lavoisier's work, people didn't believe fire was basic, but they were still committed to earth, air, and water, and those correspond to phases of matter, right? Earth, solid; air, gas; and water, liquid. And so one of the really interesting things you see is that this is really a fundamentally different perspective on thinking of the elements or the phases. Well, what happens in the 19th century and the late 18th century is people suddenly have a phase-independent concept of matter, right? Mm-hmm. And these are all the elements in the periodic table. Radical restructuring, and that's when chemistry really takes off. Mm-hmm. And what I've argued is that, and in the first chapter I go through definitions of life and theories of the origin of life and point out just how Aristotelian they are. And I give arguments for thinking that this is really kind of maybe a mistaken way of thinking about life, particularly since we're dealing with a single example of life. Mm-hmm. Namely, all life on Earth is descended from a last universal common ancestor. And even worse, most of biology is basically based on multicellular eukaryotes, plants and animals. I mean, that still is. People worry about the microbes because they don't fit very easily into the categories that we have for multicellular organisms. Things that we take for granted about Darwinian evolution become really different when you're looking at the microbes. The microbes engage in horizontal gene transfer. Basically, they can change without sex or without even, daughters. I mean, they can literally swap genes while it would be as if you and I shook hands and my eye color changed. I don't know what your eye color is, but supposing we had different colored eyes. I mean, it's really quite astonishing. You don't see anything like that in multicellular eukaryotes, except insofar as they are infected by viruses. So that's just one of many So there are examples now, the metabolic strategies of microbes. They've recently learned that it's very extensive among bacteria, that bacteria engage in not only digestive processes outside of themselves in the environment. They excrete digestive juices. Spiders do that, so it's not such a big deal. But they actually have extracellular electron transport chains, which were always thought to be bound in membranes. So the whole cell-based theory of life is, has an interesting, now people get mad at me when I say this, interesting challenge, because we've now seen microbes doing things that we didn't think that animals and organisms did, right? And so I think that we ought to sort of reconceptualize our thinking about life from a microbial perspective, and then try to treat complex multicellular organisms, plants and animals, as what they are, outliers. They're outliers.
Well, that's interesting.
They have the least genetic and the least metabolic diversity of all life on Earth. It's the microbes that are the champions, and they're also the oldest form of life on Earth.
Sure.
So that's what the book's about.
Well, it sounds fascinating. It's that's very nice. It'll be coming out, so I imagine you'll be finishing in January.
That's my hope.
That's a hope.
By this time next year, it will certainly be finished and hopefully almost out. I don't know how long they'll take, but Cambridge seems very eager for it, so hopefully they won't move too slowly. Sure.
Well, that's great. Yeah, no, thank you for giving us a little bit of a taste and an insight into what sounds like a very, very exciting and interesting book. Yeah, so it sounds like these are some of your current projects. Is there anything else you wanted to discuss, or anything else you're working on, or anything else you've been excited about?
No, I think those are my projects for the future. Except that this is kind of exciting. So I actually proposed to the University of Colorado administration a project, an origins project, and because of my work on historical science, I think of historical science as the study of origins, and there are all kinds of interesting questions about, what really are origins? How do you study them? How does it differ, of course, from how you study, things forward? How does our understanding of origins affect the future? And it turns out that, of course, origin studies are common in all fields. Yeah. They're common in the natural sciences, the social sciences, and also in the humanities. And so I proposed, as part of a Grand Challenge initiative, I was on the committee, I proposed a project. You
guys have the Grand Challenges too? I didn't really
Yes, and and I was on the steering committee, and everybody wanted to do things like, clear, so the Grand Challenges were all very technological. They were things like clearing the Earth of near-orbit debris. I was getting kind of disgusted because they were supposed to bring in the humanities to do these things, and they would
Doesn't sound like it, yeah.
No, they weren't. And then the education department was going to be brought in because they could teach
the science or the technological stuff.
I was getting very annoyed.
Sure.
And so I proposed this center for not a center at the time, this origins project, and laid it out. And then I had a linguist who was very interested in Native American language join me, and pretty soon, all these people wanted to join it. I mean, natural scientists, social scientists, and humanities people. I was astounded at the interest in it. And so I wrote this proposal, and then after it was written, they initially rejected it. People there were mostly scientists, and they said, this is too vague. This is really want. And I argued, well, this is a grand challenge, unlike your challenge.
Yeah.
But if you want a grand challenge and you want it to include all the different disciplines, this is what you want. And the university administration loved it.
Oh.
And they funded it. And so now we're putting together a Center for the Study of Origins, and it's geared towards Arizona has something, and we're going to be contacting.
Yeah, the ASU has the Origins Project.
Yes, and we're going to be contacting them as soon as we get ourselves bootstrapped. Mm-hmm. But it turns out that the interest in this is just enormous, and I think we may be a little different than Arizona in the sense that we're really looking at as one of the natural scientist Steve Moy just said today, we had a meeting today, he goes, what we really want is a theory of origins. And I thought, wow, that's kind of what I'd like. And so we're getting everybody together to really hash out, how do different disciplines study origins? How does the study of origins in different disciplines differ from the study of the future and transformations? And how do origins studies, how do you apply paleoclimate, what you learn from paleoclimate studies to climate change. And so we're really, I think it's much more of a research project at this stage, and it's kind of a Tower of Babel right now. Mm-hmm. But the excitement is just quite amazing. And so that's my other big project. We're just literally have proposed the Center for the Study of Origins and are hoping to get funding for this. The university is helping us get funding because they funded us temporarily. So that's a really exciting project, I think, and it's really up my alley on the historical science. So I'm going to be moving in the direction of really looking at historical science. And I'm very interested in modeling. Modeling is the big thing here at Boulder in the geosciences. Mm-hmm. Of course, my background in computer science and math just makes me in an excellent position to study that. And,
so are there a lot of philosophers who work in geology and the geological sciences?
I don't think so. I think I'm one of the only ones, if not the only one.
Okay. I have a fellow graduate student friend actually who loves geology. I think he just presented something at the GSA, but I'll have to mention it to you.
Are you going to the meeting in Atlanta?
I unfortunately not this year. I went last 2014.
So I'm going to say your friend should look me up.
I'll certainly pass along his name. Yeah, his name's Ali Mirza. He does really, really fun, great work, and he's interested in history of science and philosophy of science. But he's, I'll put you guys in contact.
I would really like to see more people. I mean, we have tons of philosophers of biology and tons of philosophers of physics. But there are a lot of areas, and we're beginning to have philosophers of chemistry, not as many. But there are a lot of areas. I think the geosciences and the historical sciences are going to be the 21st century biggie, like biochemistry was in physics for the 20th century, because they're making amazing progress. We have planetary science, which is really historical science, most of it. It's geology done on other planets.
Yeah.
And a lot of it's historical, reconstructing the ancient climate of Mars. Was Mars warm and wet? If so, how warm and wet 3.8 billion years ago? So I actually think that I would like to see many more people doing philosophy of the geosciences. And hopefully, it'd be nice if people came here to study with me. But as I said, that's the other thing I have to work on, is trying to getting us to be more of a center of philosophy of science. But I think there's promise. I think there's promise because I said Raul Saucedo, very interested in physics. We're getting Heather, and hopefully we will be getting other people too.
Yeah, it's interesting. I've talked to just a few people now, but it's interesting to hear some of the stories of how some of these, like, for example, the science studies program formed, or how the logic and philosophy of science. It seems like it just takes a few folks, faculty members who just are generally interested, to form some sort of a program or some sort of forming its own department is going to be difficult, but forming a program has the ability such that you can maintain positions in your own department and then have some of these sort of outside. I forget how the cognitive science program at IU was established, but that was sort of the idea, is that people wanted to do more interdisciplinary work, or wanted to focus more specifically and other than just doing psychology or just doing computer science. They wanted to bring people together.
So we actually have an advantage, because I basically rescued and resuscitated the Committee in History and Philosophy of Science and have really built it up. Every year we have a conference. This year it's on gravity. Now that I'm the director of the Center for the Study of Origins, I can no longer really run that program. But we last year got a sponsor, somebody who donated when they died, money for for history and philosophy of science. So I'm hoping, and hopefully Heather is, I think, the one who's going to run it. Hopefully. We will have a Center for History and Philosophy of Science in addition to the Center for the Study of Origins here. If that happens, we're well on our way to doing what I've always hoped we do.
Well, I hope that's the case. I hope we'll be, seeing philosophy of science represented more at Boulder.
Yeah. Well, if we can get that center going, and we have the money now to make the case with the Foster funds, I think that may well happen. So that's very exciting news too. So a lot of exciting things are happening here. I'm thrilled to hear about the book. I'm thrilled to hear about the climate modeling coming up, and again, the Origins Center is very nice. I know, at ASU, at least they've made a really great stand as far as the public perception of the project. They hold a lot of really great public talks.
I don't know if that's something with what
Arizona.
Yeah. So I think there's something there's a public outreach is a big part of the project as opposed to. So I don't, to be honest, like I originally thought that was kind of like what the whole thing was about. I thought it was primarily, but I don't know, kind of an outreach where they organize, they bring in.
That's the impression from their website, I guess.
Yeah, so it's possible that just by origins, it's just to kind of bring together folks who have been doing this from other places.
That's the impression from the website. Though it's not obvious. It could be doing more than that. We will certainly be contacting them eagerly once we get all the busy stuff that we're working on now done. We are going to eventually, next year, we're going to be looking for visiting scholars.
Oh.
And so people on sabbatical who want to come do origins work, we'll have one from the natural sciences, one from the social sciences, and one from the humanities.
Okay.
And the idea was these people would come on sabbatical, and we would pay their living expenses here, give them a couple of $1,000 a month to be. Yeah, and so they would come for a semester or a year. And so we've got space now.
I wouldn't want to go to Boulder for a year either, too. I mean, come on. It's like one of the greatest places in the north, and the continental U.S. to spend your time.
Although we haven't any snow yet. I'm getting worried about that.
Oh, yeah.
The coggle switch on climate, right?
Yeah. Oh, gee. Is mid-October around the time that snow usually comes in?
We haven't had any snow. We haven't even had a hard freeze. We have gotten down to 32 degrees Fahrenheit, and that's as low as we've gotten so far.
Oh, geez.
Stunning. It's stunning.
It feels like it's
weather. 8-degree weather. And, by the time in October, you've had basically hard freezes, and you usually had 4 or 5 inches in the snow, snow on the ground. Now it melts off pretty quickly at this time of year, but this is really bizarre weather.
Yeah.
So.
Well, Carol, it's been a really good pleasure getting to chat with you. I've learned a tremendous amount about your work, your projects, and the way you've told some of these really great stories about your early life as well has been really enjoyable. So thank you so much for coming on. Is there any other final thoughts or words you'd like to say? Any recommendations or things you'd like to put out to listeners who might be listening in on this?
Well, I would really like grad students to consider studying the geosciences. I think getting more people doing geoscience and more people doing astrobiology too. But I do worry because, as I said, when you do astrobiology, I think it's really important that you really know the science and not just pontificate about it or come from your own areas and philosophical specialization. But I do know that the way in which I think I've succeeded with scientists is by making sure that, I've had scientists say to me, you know more science than I do, except in my own specialized area. And that's what we need to be. We need people to be saying that kind of stuff to us. That's the position we should be in as philosophers of science, so that otherwise I don't think scientists will respect you and listen to you. And I make sure that they do in that sense. Not all of them do.
Not all of them do. Sure.
Scientists who really don't want philosophers mucking around in their field. But there's an enormous number of scientists out there, a large number at least, I found, that really have philosophical interests. They just don't know that's what they are.
Yeah. And if you know the science so well, it's really hard for them not to pay attention to you.
And you don't have to know the bloody details, right?
No.
You do in the areas where it's pertinent.
Sure.
But if you're going to do origin of life stuff, there are just certain things that are in the biochemistry and the molecular biology that you have to know, and other things you don't need to know. And you just need to be willing to, figure out what you need to know and what you don't need to know. And that takes some studying, certainly, but it's not hard to do, really, in the end.
Great. Well, thank you for those recommendations and the kind words. And again, Carol, it's been a pleasure. Are you going to make it off to the PSA in Atlanta this year?
Yeah, no, I'm going. I'll be there next week.
Okay, great. Are you giving a talk or just going?
I am giving a talk. Yes.
Great. What's the session?
It's a session on. I think it's on plasticity. It's actually a session which I'm not sure I'm really qualified to talk on. It's on applications of historical science to issues having to do with plasticity. But I kind of agreed to do it. And
was it a symposium kind of, or?
it's a special session, and
Sure.
and the thing that's really kind of let me see if I can figure out how to describe this. It's basically on issues having to do with plasticity and biological evolution, and the person who put it, developmental phenotypic plasticity in particular, and the person who put it together really thinks that stuff I've done in historical science might be useful for teasing out which phenotypic variations in a particular lineage are generated by natural selection, operating on environmental initiated novelties, as opposed to mutationally induced novelties. I'm not sure whether that's the case. I have to really think about that starting about tomorrow.
Oh, okay. Yeah. I suppose it's coming up pretty soon.
Yeah. And so I just don't know. And so I'm not sure I will have as much to say as I would perhaps like to have to say.
Sure.
But it's not an area that I'm working directly on, so I didn't feel I'd spend a lot of time on it. But I will talk about my work in historical science and how you might approach these issues using those tools.
Okay. Well, I just brought it up here, and well, best of luck preparing for the session, and I hope you have a wonderful time in Atlanta. And like I said, it was wonderful talking with you, and if you're ever in Indiana, do come say hello.
Yeah, I've been there twice. I've been there twice. I gave a talk there a couple of years ago, and I gave a talk, I guess, 2 years ago to one of your, I think it's Lloyd Lab or something like that.
Oh, yeah. Oh, okay.
Yeah, so I've been there twice, so hopefully I'll be back again sometime.
Yeah, sure. I mean, Bloomington's it's a lovely town. Sounds like you frequented it before, and yeah, we'll see what we can do.
I certainly enjoyed having historians. We don't have any historians of science here. There's just no interest in the history department here in history of science.
Really? Is it like continental history or just all?
They're not even interested in origins. We try to get in to do origins. They don't want to do origins.
What do they want to do?
I don't know.
You're just not that. Yeah, that's too bad.
And it's been very disappointing to me.
Well, it's